So we've talked about writing equations of lines. Now we're going to add a twist to it when we talk about writing specific equations of lines with the stipulation of the idea of parallel versus perpendicular. Now when we talk about parallel or perpendicular, there's a couple of things that you need to know. So when we talk about parallel lines, the key is that when we talk about parallel, we're talking about lines that never intersect. So when we say things are parallel, we mean that they never intersect. Now, you might ask, how does that relate to lines that we're talking about in this class? Well, if we're talking about two lines that never intersect, we're talking about two lines that have the same change vertically and horizontally. They change at the same rate vertically and horizontally. Now that might seem familiar because if we're talking about the same rate vertically and horizontally, that means that they have the same slope. So two lines that are parallel have to have the same slope. So when we talk about lines that are parallel, they have to have the same slope. So the first example that we talk about is one that has 2 points and another line that has 2 points. So it says, is the line containing the points whose coordinates are these right here parallel to the line that has these 2 points? So what that means is that we have these 2 points here, -2, 1, and -5, -1. So we have this line here. And I know it's not perfect. And you don't have to draw a line for this. But we have this line, and we have 1, 0, and 4, 2. And we're trying to figure out if they look parallel. Well, they might look parallel, but we're not 100% sure, and you can't tell based on my drawings because they're not the best drawings. So the question is, are they parallel? Well, if they are, they have to have the same slope, and we have a way to find the slope. And the way that we find slope is right here. So let's see if we have the same slope here. So I'm going to find the slope of these two points. So -1 minus 1 over -5 minus a -2. And I get -2 over, that changes to a positive. We get a -3, so this changes to a positive 2/3. So my first line, this first one that I had drawn here, is a slope of 2/3. So it goes up 2 and over 3 for any 2 points that I pick. Now I'm going to pick these two here. So 2 minus 0 over 4 minus 1, which reduces to 2/3. Notice they have the exact same reduced slope. So they have the same slope. So they are parallel. So they're parallel because they have the same slope. Now, you might be asked to write an equation of a line rather than just tell if things are parallel or not. And you can see here it says to find the equation of a line that contains a point and is parallel. Now, from the previous section, we have this equation that we're going to use. And remember, we have a point and a slope. So we need that information. So we have a line that has a point, but it doesn't tell us what the slope is. So I'm going to write down what the point is, but I'm going to leave the slope blank for a minute because I don't know it, because it doesn't tell us exactly what the slope is. But we do know something, that it is parallel to this line. So we know it's parallel to that line. Now, if it's parallel to that line, we've already got done saying that things that are parallel have the same slope. So we have to ask ourselves, what is the slope of this line? What is the slope of this line? And the slope is the number in front of the x, or the coefficient of the x. So that right there is the slope. So if it's the parallel line, we have the same slope. So I'm going to plug that in because it's parallel. So now I have my slope and my point. So now I just need to solve this for y. So what I'm going to do is I'm going to distribute this to both terms. So I get y minus 3 equals 1/2 x. 1/2 times a negative 2 is a negative 1. I'm going to add 3. And I get y equals 1/2 x plus 2. And there's my line. And if I wanted to graph this, I would start at 2. And I would go up 1 over 2. And I would know this is parallel because it has the exact same slope. And this one would start at 4, or excuse me, negative 4. Go down one more, up 1 over 2. And they're parallel to each other. Now, another wrench that you can throw into this type of problem is if you don't have a specific equation that tells you what slope is. So you see this equation, we have a point just like before, but we have a different line, so we don't necessarily know what slope is. So we need to find slope, but it doesn't tell us directly what slope is by that equation. So I'm going to subtract 2x because we need to solve it for y so I can find a number that tells us what the slope is. So I'm going to get negative 3y equals negative 2x plus 5. And I'm going to divide by a negative 3. And I get y equals 2/3 x minus 5/3. Now, we solved this for a y for a purpose, and the purpose is because we need some number from this, because that's telling us that it's parallel. And if it's parallel, we know it has the same slope. Well, we solved it because this tells us the slope right there. It tells us what the slope is. So we have a point now and the slope. So in this equation, y minus y1, or 4, equals the slope, which is 2/3, times x minus a negative 1, or x plus 1. I'm going to distribute both of these. I'm going to get y minus 4 equals 2/3 x plus 2/3. I'm going to add 4 to both sides to get y by itself, but instead of adding 4, I need a common denominator here. Instead of 4, it's the same thing as 12/3. 4 is the exact same thing as 12 over 3. So 2/3 plus 12/3 is going to be 14/3. So my answer is y equals 2/3 x plus 14/3. There's the equation of my line. Now the difference, the second part of this section has to deal with perpendicular lines. Now, usually I will probably, when you see this, I'm going to probably have you stop here and I'm going to have you do this in 2 parts. But since I have a few minutes, I'm going to talk about this in the same video. When we talk about perpendicular lines, we're talking about them meeting at a right angle, or a 90-degree angle. So they intersect, so that means the slopes can't be the same. So what we talk about in terms of their slopes are what are called opposite reciprocals. Okay, so an example of this would be something like 2/3 and negative 3 over 2. Reciprocal meaning flipping the fraction upside down, opposite meaning one positive, one negative. So if we're talking about a line with 2 points and another one with 2 points, if they're perpendicular, We just need to see if their slopes are opposite reciprocals. So I'm going to find the slope of the first line, 5 minus 2 over negative 2 minus 4, which is going to be 3 over negative 6, which reduces to negative 1/2. You always want to reduce slopes because that tells you very quickly if they are perpendicular or parallel or not. Now I need to find the slope of the other line. So I'm going to find the slope of this line. So 5 minus 3 over negative 3 minus a negative 4. So I would have to flip this around and make it positive. This is 2. This is going to be a positive 4, and that reduces to 1. So that reduces to 2. This is the reciprocal of that. One's positive, one's negative. They are perpendicular. Now, if we look at a graph of this, they would be perpendicular to each other. So that means they would meet at a right angle. Now, you don't necessarily need to see a graph. All you need to see is the slope. Now, the last thing you need to see is an equation of a line. Now, again, this is no good to us right now. We need something more specific, particularly what is the slope of this line. So I need to take a look at this equation, and I need to figure out what the slope is. So I need to subtract 2x. So I get negative y, because that negative doesn't go away, equals negative 2x minus 3. Divide by a negative 1. That means I divide everything by a negative 1. So I'm left with y equals 2x plus 3. Again, we do this so that I have a number that describes the slope for me. So in the equation right here, I need a point and a slope. I have my point right there. I have the slope. It is perpendicular now. So I need the opposite reciprocal. So the opposite reciprocal of 2 will be negative 1/2. So then I plug in the point. It'll be x minus 3, y plus 4. So there's my equation. I'm going to distribute the negative 1/2. So I have y plus 4 equals negative 1/2 x plus 3/2. I'm going to subtract 4, which is the same thing as subtracting 8 over 2 because I need a common denominator. So my answer is y equals negative 1/2 x. 3/2 minus 8/2 is a negative 5/2. So here is the equation of my line. And that is how you deal with a line that's perpendicular. The only difference is that you have to use the slope to find a different slope because they're not parallel anymore. And that is how you deal with lines that are parallel versus perpendicular.